Okay. Hello, students. Welcome to the session for recurrent neural network. So we will be studying recurrent neural network today. Recurrent neural network. So where we can use recurrent neural network. We can use recurrent neural network where we can find sequences, sequence, or we can say a pattern. So if we have found some sequences or pattern, we can apply the recurrent neural network. So let's define some problems so we can apply recurrent neural network. So recurrent problems. So how we can identify the recurrent problems? What are they? For example, if we consider this example, if weather is equal sunny, eat chicken, else if weather is equal rainy, then eat burger. So if we consider this kind of a straightforward problem, so we can see or we can analyze that this problem is basically a straightforward control flow program. So it's a control flow program. And in this control flow program, there is no sequence is generated. So no sequence is getting generated. And because there is no sequence is getting generated, that's why there, that's why is basically we cannot apply RNN in this sort of problems. So how normal neural networks solve this kind of problem? If we can match, we have input is weather, which is value of sunny, rainy, and we have an output which is comprises of food. It could have chicken, burger, and for example, if you consider a pizza as well, or vice versa, we can enlarge the elements of this input output set. So our problem is to map this input to this output. That means we wanted to map a weather variable to the food variables. So how we can do it? We can do it easily with the help of um, we can easily do it with the help of our MLP, like multi-layer perceptron. We can easily apply that on based on this. What are the procedure that multi-layer perceptron could be useful upon this? For example, if we consider one hot vector representation, one hot vector representation, that means if W is being comprises of sunny and rainy, then the weather hot vector representation is 0, 1, and for rainy it will be sorry for mistake, it will be 1, 0, and it will be 0, 1. So one hot vector means only one value could have could be 1. So in a vector, only one variable value will be 1, another will be 0. So that's why it is represented as one hot vector. And if we consider the food matrix, for short form we are using chicken, burger, and pizza. C for chicken, B for burger, and P for pizza. So one hot vector representation will be looks like 1 0 0. Burger will be look like 0 1 0, and pizza will be look like 0 0 1. So this pattern and this format is being known as a one hot vector representation of the variables. So if we can gather the one hot vector representation, we can easily map the previous problem, the input-output mapping problem, into an MLP. For example, let's take two nodes. We can say these are our inputs. So inputs would be weather. So we can apply this as a sunny and this would be a rainy. And we have a food matrix. So this will be our output. We are putting chicken, we're putting burger, and then we are putting pizza. So the conditions apply. If we revisit the condition says if weather is equal sunny, then eat chicken. Else if weather is equal rainy, then we will burger. So sunny producing a chicken and rainy producing a burger. So we are putting a connection which is correlated to one weight, and if the inputs are coming, then the output will be translated, or the values will be translated to these nodes. And we didn't draw the nodes, draw the arcs from the input to the output, which actually comprises of the value of 0. So uh, if we consider this as our multi-layer perceptron neuron set, we can basically form an adjacency matrix. So the adjacency matrix will be, this is an adjacency matrix. So from to, so when the weather is sunny, it's 0. When the weather is rainy, it's burger, and there is no connection from pizza from the weathers. And this matrix is basically of 2 into 3 matrix. So we need the transpose matrix. We know already that we need the transpose matrix of the adjacency weight matrix. This is the adjacency weight matrix. So after transpose, we might have this picture 1 0 0 0 1 0, and this matrix is actually representing the dimension of 3 is to 2, the transpose matrix of this matrix. And we can multiply this matrix, this is called 3 is to 2, with our inputs. We can take one hot vector representation of our input like 1 0 or 0 1. So it could be like 1 0. If we take example of this is 2 into 1 matrix, it's value of sunny. So then there will be a value generated. This matrix multiplication will produce 3 into 1 matrix. So and the value will be 1 0 multiplied with 1 0, it will produce a 1, others will produce a 0. So this value actually representing the chicken. Let's revisit 100. It is actually referring a chicken. So the output is chicken. So the mapping is being done with help of matrix multiplication. And how this neural network actually evolving? This weight matrix, this weight matrix is basically computed by the learning procedure of ML, like the delta learning process, the weight updating process that will help us to actually computing this weight matrix in a proper manner. So far, this example just show how a Boolean functionality can be represented with help of MLP. So let's move on. This is not applicable for recurrent neural networks, right? Because recurrent neural network demands sequence and also needs to produce sequence as well, or a pattern. So how the recurrent neural network is different from MLP? First of all, architectural difference. What are the architectural difference of multi-layer perceptron? The difference of multi-layer perceptron in the architectural difference is that if we consider the architecture of a multi-layer perceptron, for example, we can see the basic architecture of a recurrent neural network is basically looks like this. There is a time series input of xt, and there will be some hidden state coming from recurrent or feedback from the state, and there will be some output generated by the ht. So if we expand this thing could be expanded and could be represented like x0, it will produce h0, and then it will be denoted as h1, x1, same a function, just this is an unfolding manner of time series, right? So h2 and move on. So that is the procedural of the weight matrices. And if I consider more elaborately about this hyperbolic or about this architecture, then we can basically depict the architecture in much more different manner. Like for example, if this architecture looks a little bit clumsy, we can reformat this architecture with help of our known picturizations. Like for example, if you consider this as our uh, recurrent neuron, then this will be the x vector with coming with associated with hx. For example, this we consider this as h function. This h function is coming with input x associated with hx suffix. That means neuron j is h and x is the input from where it is coming. So, and then the output will be generated at y, and this is actually associated with yh from h till y, and there will be some recurrent folding which actually denoted hh. So weight matrix will be multiplied with hh. So if we consider this as our recurrent neural architecture, we can distinguish or deformat it, the recurrent neural network architecture, into these states like ht, and it would be ht plus 1 So there will be propagation, and in this layer xt minus 1 is coming input, and in here it will be xt t time sequences, and it also xt plus 1. So, and how the generation is going to be happen, it actually started with whh with value of some this we say actually the unfoldation of this architecture. So it will generate a y that will be t minus 1, and it will be generated with the help of YH matrix, and this matrix is passed to WHH. Similar weight matrix will be passed later on, and this matrix will be HX T minus 1. Actually, we can say it, if the weight matrix has been considered, we can use HX and also WHX, WHX, and here the passes of WHH with matrix, and it will generate WYH with YT, and it will generate YT minus 1 with the help of W of YH. So this is the basic architecture that actually represents a recurrent neural unit. It's a recurrent neural unit. All the functionalities of a neuron will also comprises in this architecture, but it is actually associated with some hidden states and some functionality. So that's why it is a little bit of different from recurrent neural network. It can comprises of feedbacks, and that's why it is a little bit of different from the uh, traditional MLP or traditional neurons. So uh, that is the first difference of architecture that it can have with differences of. And the second thing is the multi-layer perceptron. It cannot be applied upon sequences because it cannot hold any kind of previous information. All the informations are ongoing or passing the information for from input layer till output layer. All the information passes in single pass. So that's why we cannot apply long contextual situations sequences in MLP for prediction. So that's why, for example, if we consider a situation, if we consider an example, I am traveling to Europe now. I am at Greece after traveling from Germany to Germany to, for example, Rome in Italy, and after that we have visited Then France, then I guess from Germany to Rome, France, and Switzerland. In France, I need to communicate with people in language. Here you can see that in the fill in the gaps, which language will be provided will be a contextual information. And because the recurrent neural network can process sequences, so it can go and extract the information of France. And also in France, there is some communicative process of French. So that's why the appropriate word comes here is French language, which cannot be performed in multilayer perceptron because multilayer perceptron is on the single flight neural network, so it will not be able to process or remind or capture the context of previous sequences. So for that, there is an upper hand of RNN. Upper hand RNN is used to capture the sequences which hold the context. But there is a limitation. There is a limitation. It cannot process or provide correct prediction if the sequence become too too long. Why? Because our memory is basically based upon some events, and some events is our memory, human memories, are work like shuttle points. What is shuttle point means? Shuttle points means we cannot hold longer memories. For example, if I say I eat rice every day, in first our neuron will hold I. That I is basically 100%. And if after that we are actually providing our next sequence with the memory dividing of a space with 50%, then if I move to forward and then we have eat and then we have rise, our memory gets shrink to 30%. So after a certain amount of time, the memory will consume the y in 1% or a little bit of more less significant. So this longer sequences longer sequences will wipe out incidents from the context. And that's why RNN suffers from vanishing gradient problem. So longer message would not be processed or would not be able to be processed by RNN. So that's why the RNN actually suffers from vanishing gradient problems. Not only vanishing gradient problem, it also suffers from another problem which is called exploded gradient problem. So exploded gradient problem is similar like vanishing gradient problem, just the gradients will get bigger and bigger will get improve impact upon the weight update rules and might the weight update is getting oscillated. So both this operation is actually based on the gradient, right? So the gradient portion is either big or either small. When the numbers are getting very small, then vanishing gradient problem occurs. When it gets bigger, then exploded gradient problem occurs. So for removing the vanishing gradient problem, RNN takes help of LSTM to omit the vanishing gradient problem. LSTM was introduced where L stands for long, S stands for short, T stands for term, M for memory. So the term short-term memory will be recalled for long period. So that is the way the LSTM basically works and it resolves the problem of RNN vanishing gradient series. So in the RNN architecture, in the RNN architecture, you can have a look that this architecture is shown that some sequence from xt to yt is being generated. So these sequences could have four different formats. So which are can be represented as 1-2-1 representation of RNN, one to many, many to one, many to many. This could be mapped as word to word, word to sentence, sentence to word, sentence to sentence. So one could be replaced with word and many could be replaced with sentence. So there would be some different variants of RNN which could be represented like predicting the next word by seeing a previous word. That could be represented as word to word. Word to sequence means if you provided a single word, you need to produce a paragraph. That means word to sentence. Sentence to word means you have provided a context or a set of paragraph and then the word will be predicted. then sentence to word will be produced, and sentence to word problem will be solved by the RNN. Sentence to word are quite similar to our emails or Gmails feedbacks. Gmail's feedbacks could be the example, proper example of this factor. And sentence to sentence means what ChatGPT actually does. If you provide a sentence, and basically it actually generates and keep answering you with the sentence. So that's how the four different formats of RNN actually works, and the architecture of this four could be represented in like x1, x2, x3, and then there will be only one y. Okay. So this will be provided the chain rule, and it could be predicted as sentence to word, where y represents as word and x is a sequence of sentence, and a is the recurrent neural network, where the middle ones is the hidden state that it actually work upon. So let's get back to the interesting problem. Like we have seen, the weather maps with the food using MLP. So let's think about a scenario. Think about a scenario where there is a shopkeeper who has a food of series of chicken, burger, pizza, and shopkeeper always tries to ask you, if you go to this shopkeeper, it always tries to ask you a question: what you had on previous day. Because you're a regular customer, that's why shopkeeper always asks you, because he has a very rush of the customers, so he asks you that what you had on the previous day. And the food you had on the previous day that will be provided to the next day is different. For example, if you had a week, Saturday, Sunday, Monday, Tuesday, Wednesday, Thursday, and Friday, if you actually says that on Saturday you were having chicken, and on the Sunday you move to the shopkeeper and asks that I the shopkeeper asks you the same question, what you had on the previous day, and you have answered that I had a chicken on the previous day, then the shopkeeper is providing you a burger which is available for you in the next day, because he has provided you a chicken. So shopkeeper basically tries to provide you the next food item on his shelf which you didn't have on the previous day. So for example, if you move to the Monday, shopkeeper asks you same question, what you had on previous day, and you have answered you had burger, then shopkeeper tries to put you a pizza. Then on the Tuesday, because all the items of his restaurant is finished, so shopkeeper tries to reiterate the items for you. For example, on Tuesday, it will reiterate from chicken, and then it will move to burger on Wednesday. On Thursday, it will be pizza, and on Friday, it will be chicken, and moves on. The next Saturday, it will be a burger. So upon the day basis, your food is not being confined with the shopkeeper. The shopkeeper always tries to provide you the next day food, which is basically not being served to you on previous day. So that's the main fundamental catch, and that's why we can say that shopkeeper always tries to maintain Shopkeeper always tries to maintain what? Shopkeeper always tries to maintain this sequence. Chicken, if he provides chicken, then he will move to burger. If he provides burger, then he will move to pizza, and pizza will be referred after that in chicken. So shopkeeper tries to maintain these food item cycles. So there is a sequence of pattern, right? After chicken, there is will be burger, there will be pizza, and after that the cycle repeats. So this is a generation of sequence. Generation of sequence. And to solve this generation, to solve this generation, we can to solve this generation, we can apply RNN, recurrent neural network. How we can solve this with the help of recurrent neural network? Let's assume chicken, burger, pizza. We had it chicken, burger, pizza on previous day, and in the next day we have chicken, burger, pizza again, right? So the shopkeeper asks what you had on previous day, and after being answered chicken, the shopkeeper will try to give you a burger. And if it is a burger, then shopkeeper will try to give you a pizza. And if it's a pizza, shopkeeper will try to give you the chicken. How does the recurrent works? Recurrent works. Chicken will go back to chicken again. Burger will be go back to burger again. Pizza will go back to pizza again. So this is how basically the recurrent structure works. Normally, recurrent neural network works like chicken, burger, pizza. Chicken will be crossed, burger will be crossed, pizza will be crossed. So if I consider these individuals as RNN, so extracting or segmenting them into a two parts like previous day and next day, we're actually generating the recurrent neural network for generating this sequence. And how the sequence gets generated, if let's consider how this uh, generation is basically be done. Let's calibrate. Let's calibrate how this generation being done, right? So this generation is being done a little bit of having a little bit of trouble. Okay, so let's consider you have uh, on Tuesday. So on Tuesday you're having a chicken. So 010. This is Tuesday. Okay, so this is the Tuesday we are actually referring. So what about the Wednesday? So 0 will be fed into burger, 1 will be fed into pizza, and this 0 will be fed into what? Chicken. So on that day, if you have uh, 0, 1, 0, that means, okay, my mistake is it will be, if it's Tuesday, it could be chicken. So chicken will be 1, 0, 0, and the movement will be, it will be 0, 1 will be passed from here, 0 will be passed from here, and this is being generated for Wednesday. This is Wednesday. And this result will get feedback. This result will get feedback 0, 1, 0. This is a Wednesday, and this will generate the Thursday's output. The Thursday's output is 0, 0, 1. This one will go to the pizza, and 0 will be going to the 0, and this 0 will become to the 0. So this zigzag will definitely produce a Thursday. This is a Thursday, this is Wednesday for next, and this is the Tuesday, and this is the Wednesday, and Thursday will be move on to 001. So basically, the recycling pattern, the main topic is which is the next day is going to become a previous day for the next day. So that is the catch where the sequence is getting generated. And for that, we have this generation process, and we can easily we can easily make this generation work for the RNN. So how the matrix will be formed, if we consider the adjacency matrix, we will have from 2. If I had a chicken, then I'll have a burger. If I had a burger, I'll have a pizza. And if I have a pizza, then I'll have a chicken. So this is a 3 into 3 matrix. It will be reshuffled with transpose. With transpose, this will turn into 0, 1, 0. The rows will be become the column. 0, 0, 1 will be 0, 0, 1. 1, 0, 0. So it is a 3 into 3 matrix, was a transpose matrix of the adjacency matrix. And if you're actually multiplying with some food, it also 3 into 1, it will produce 3 into 1. This is a basically chicken, and there's the weight matrix. And if you multiply it, 0, 0, 1, it will produce a 0, 1, 0, 0, it will produce a 1, and it will produce a 0. So this will produce a burger. So weight matrix is referring which next food can we perform or can we get. And definitely these weight matrices are computed similar fashion like multi-layer perceptron. So as multi-layer perceptron, this these matrices are actually being formed or being calculated, right? So in the previous example, in this previous shopkeeper example of sequence, we get a sequence, we have get a sequence, and this sequence is for shopkeeper part. The sequence, this is the sequence that the shopkeeper is referring to us, and with the help of this reference, we basically get a previous day food and the next day food. But the main theme is in the first example, there is a weather mapping towards the food, and in here there is no impact on weather for on the shopkeeper. So let's think a little bit of complex problem which has an impact. Let's introduce impact of weather in the problem, in the generation problem. Like let's take Saturday, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday. Let's take, for example, uh, on the Saturday, there is a chicken I had, and it's a sunny day. So there is a forecasting of sunny, rainy, rainy, sunny, sunny, rainy, sunny. So there is a forecasting of weather. So if weather is sunny, I can go to shopkeeper and he will provide me next dish on the cycle. Because I can went to the shopkeeper, He asks me what I had in the previous day, and he will prepare or cook for me for the next meal that I had previous. So that's why if the weather is sunny, I could reach to the shopkeeper. If weather is rainy, I cannot go. So I had to eat previous dish. So I had to have previous dish. For example, in the sunny, chicken and sunny, the weather is sunny, I could go to the shopkeeper and shopkeeper will prepare a burger for me. Because burger and rain happens, so burger and rain happens. Rain happens means I have to stay at the home. I could not go to the shopkeeper, so I had to eat burger again. So in the burger, in the next day, there is also rain, and I had a burger. So I had to have a burger on next day as well because I could not go to the shopkeeper. I could not change my diet. So on the Tuesday, I can go to the shopkeeper because it's sunny weather, and that's why I could have my next meal. He asked me what you had on the previous day, and I have answered that I have a burger on previous day, and that's why he suggested to give me a pizza on the next day. What will have happen? What will happen on the next day? There is a sunny weather and there is a pizza, and we will be having I think the pizza and sunny weather, the next meal in the cycle, and that is chicken. So we are actually following this cycle as well for the shopkeeper, what we had on the previous example, because chicken, after that, shopkeeper will provide a burger, burger after that, it will provide a pizza, and after the pizza, it will be providing the chicken as well. So the chicken and there is a rainy happens, and because of the rain, I can only have chicken on the next day. And is because this is sunny weather, I can move to shopkeeper, and shopkeeper will provide me a burger. So that will be my second. Uh, on Saturday, I can have a burger. So there is a change pattern and generation of food sequences, and this sequence has been generated with the help of weather consideration or weather input. So we can map this problem into a weather matrix plus previous day food matrix. It will produce our next day food matrix. So we are actually going to see this example as a recurrent neural network, how we could solve it. So let's try for the solution. How we can solve this problem. So let's think how much input we can have. We have food as our input, which has chicken, burger, pizza, and we have sunny weather and rainy weather. So two weather variable elements, two elements of weather, and three elements of food. These are basically the inputs of my problem. And in this input, food is getting recurrent. So that's why chicken, burger, pizza, those will get recurrent from the output layer. So it will generate some output, which is basically the food matrices. So there is a mapping of inputs and outputs. Why it is called recurrent? Chicken, burger, pizza. So that's why it is actually going to recurrent. Now, what we could do, when we have a sunny weather, then we can go to the shopkeeper and change our food. But when it's a rainy weather, we have to have the same food. So let's discuss. This could be the same food, and this could be the food on the next cycle. So same food, translate it, different food, that means the cycle. So if I had a chicken on the previous day, I'll have a burger on the next day. If I had a burger on the previous day, then I'll have a pizza on the next day. If I have a pizza on the previous day, then I'll have a chicken on the next day. So this denotes the next food of cycle, and this denotes same food of cycle, same food. Okay, so here one thing needs to be observed, that is there is a sunny is one variable and rainy is one, and we need to add our food matrix with the weather matrix, so the dimension needs to be same. So if we do that, we need to repopulate the dimension, and because there is a 6 nodes in the upper hand, we need 6 in the lower portion as well. And in that 6, 3 will be sunny and 3 will be rainy. Why? Because the food elements are 3. So we are actually trying to capturing all the combinations of the food with the weather. So from there, we can say that if the weather is sunny, then from S the values will go. And if the weather is rainy, the values will be dive into this. For that, now in the next layer, we are actually trying to combine of what? A chicken plus we are combining rainy. How this connection is going to be happen? If the rain occurs, we are remaining at home and we are having the same food. Which is the same food? The first chicken. This is the same food. And what happens if it rains? So the rain comes. So these two nodes actually denoting I'm having the same food if a rain occurs. So that's why chicken plus rain, where this chicken means same chicken, not the different chicken. So that's why the first node is being there, right? And for burger, also the same food, right? We can and pizza. So if we denoted this as a burger plus rainy, pizza plus rainy, right? Then the rest is chicken plus sunny, burger plus sunny, pizza plus sunny. So how the arcs are going to be added? This is the next day that I can have the chicken and I can have a sunny weather, burger and the sunny weather, pizza and the sunny weather. So that's how the calculations of all possible combinations is being calculated in this layer. And we can call this layer as addition layer. This is an addition layer. And after that is basically we tried the normalization. Some addition will generate some values which are not one hot encoded values. So to remainder the one hot coded vector remainder values, like the value should be in between 0 and 1. So that's why we do a normalization step. Normalization step. And after that, it will produce chicken. This is, sorry, rainy, burger plus rainy, pizza plus rainy, chicken plus burger plus pizza plus, and this chicken and this sunny weather will come comprising together, producing chicken. This will producing burger, and this will producing pizza. So that's how the full set is going to be happen, right? So if the full set is going to be happen, and that from there the chicken, burger, and pizza is going to be recurrent, and the weathers are going to be change it. So let's revise an example so that we can easily cope up that what actually happened. So for example, let's pick a day of burger and sun. Like the inputs will be burger and sunny weather, and what we will be getting and generated from this recurrent neural network. Let's observe. So for burger, it will have 0. Let's remove the input set. It's a 0 1 0 burger. So burger means it will 0 1 0 is the input, and sunny means 1 0 as an input. Let me just, it is actually getting to, yeah. Okay, let's revise it. If it is 0, then it's a 0. If it is 1, then it's a 1. If it is 0, then it's a 0. Then 0 is going to be 0 here. 1 is going to be 1 is going to be for pizza, and 0 is going to be for chicken. So same food and different food is there. So 1 is going to dive, deep dive, deep dive, and others are 0. Okay, so these values are basically, we need the arcs. That's why I cannot move the full arc set. But let me try. Okay, let's just redraw it. So it's a rainy part. So rainy part will be moving to this up. So 0 1 0, and it is 0, and it is 1, and then 0 1 1 1 0 0 0. The translation looks like this, and then the 0 and this 0 is generated from it is 0 and rainy is 0, right? So these low three are rainy. So this is sunny and rainy is chicken, burger, and pizza. So rainy is providing 0 and 0, so it is producing a 0. 1 and 0, it is producing 1. 1 plus 0, it is producing 1. 0 plus 0 is producing 0. 0 plus 1, it is producing a 1. 0 plus 1, it is producing a 1 again, and 1 plus 1, it is producing a 2. See, there is a 1 factor that comes 2, 1 plus 1, 2. That means this factor is out of one hot vector. So we need to normalize it. And how we will normalize it? By dividing all the neuron values with this number. So if we divide 0 by 2, it will produce a 0. 1 by 2, it will produce a 0. 0 by 2, it will produce a 0. 1 by 2 produces 0. 1 by 2, it will produce a 0. 2 by 2, it will produce a 1. So now our all the values becomes one hot vector values. Only 0 or 1, no other values than one hot vectors. So then if we merge it, simple way, so we could merge it very easily for that. I think okay, so it would be 0 plus chicken plus this 0 and this 0. So 0 plus 0 is 0, and there will be, let's consider it b, so it will be 0 again plus 0. So r plus s is going to be removed and the values will be get added. P is a 0 and here P is 1. So the value finally gets, the value of this gets 1 and the value of the upper 2 is getting, this is a 0 and this is a 0. So that the 0, this 1 means it will be recurrent to here, and this one means if it's chicken, burger, pizza, then I'll have a pizza on the next day and it will recur, like it will have 0, 0, 1, and the weather will decide if it is going to be the same or the difference. So that's how the recurrent neural network actually works. And we can add any more variables, like we could add the factor of, like, considering friends plus weather plus food, and also different parameters to make the problem more complex and more oriented, right? So that's overall recurrent neural network is, and you can skip study upon the recurrent neural network in the slides as well. This is just a basic preliminary brief how recurrent neural network could solve different problems with help of different alliances. Thank you very much for your session and uh, for your patience. And I think we will be seeing on the next chapter. Thank you very much.